Day 845 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2904, shortest and lexicographically smallest beautiful string. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a binary string s and a positive integer k. A substring s is beautiful if the number of ones in it is exactly k. Let len be the length of the shortest beautiful substring. Return the lexicographically smallest beautiful substring of s with length equal to len. If s doesn't contain a beautiful substring, return an empty string. A string A is lexicographically larger than a string B of the same length if the first position where A and B differ, A has a character strictly larger than the corresponding character in B. For example, the string ABCD is lexicographically larger than the string ABCC because the first position they differ is at the fourth character and D is greater than C. All right, y'all. So that may seem a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we're doing this problem correctly. So in example 1, we have our input s equals a string 100011001 k equals 3. So we want to find a substring or where that is beautiful, so the number of ones in it is exactly k. So we want to find the shortest substring with 3 ones because k equals 3. The output is a string 11001, which is a substring out of this. Explanation says there are 7 beautiful substrings in this example. So this right here is a beautiful substring. As you can see, has 3 ones. This right here as well has 3 ones. This right here as well has 3 ones. This has 3 ones. This has 3 ones. This has 3 ones, and this has 3 ones. But we want the shortest one, which is this one right here that's highlighted right now. And it says with a length of 5. It says the length of the shortest beautiful substring is 5. The lexicographically smallest beautiful substring with length 5 is the substring 11001. Once again, that's this one right here. So that's the one we return right here. Boom. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, our input s equals a string 1011, k equals 2. The output is 1, 1. Because remember, k equals 2, that means we need to find a string or substring with 2 ones. Explanation says there are 3 beautiful substrings in this example. The substring 101, 011, and 1, The length of the shortest beautiful substring is 2. The lexicographically smallest beautiful substring with length 2 is substring 1, 1. Boom, that's this one right here. So that's the one we're going to return. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, our inputs s equals string 000. This time k equals 1. As you can see, there are no ones in this string, so we return a blank string. Explanation says there are no beautiful substrings in this example, y'all. So boom, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we're going to do is we're going to convert the string into an array of characters so that individual characters can be accessed by index. So we're just going to declare a variable called r and set that equal to an array, open up the parentheses, pass in s. Then we're going to get the length of the string. So we're going to declare a variable called length and set that equal to r.count. Boom. Then we're going to store the best beautiful substring found so far. So we're going to declare a variable called cur and set that equal to string and put the parentheses. Boom. Now we're going to count how many ones are currently inside the sliding window. So we'll declare a variable called count, set that equal to 0. Then the left and right boundaries of the sliding window, we'll declare a variable called left, set that equal to 0. Declare a variable called right, set that equal to 0. Boom. Then we're going to expand the window by moving the right pointer. So we're going to say while right is less than left. Then we're going to open up the brackets. If the new character is 1, we're going to include it in the count. So we're going to say if R square bracket right equals quotation mark 1, let's open up the brackets and we're going to say count plus equals 1. Then, while the current window contains exactly K1s, try shrinking it from the left to find the shortest possible valid substring. So we're going to come underneath this if, and we're going to say while count equals K. We're going to say and left is less than or equal to right. We're going to open up this bracket and the current substring represented by the window, we're going to say let current equal string, open up the parentheses, R square bracket left, dot, right. Boom. Then we're going to come underneath this and we're going to say let cur length equal right minus left plus 1. Boom. Then we're going to update the answer. If no answer has been found yet, the current substring is shorter and the lengths are equal, but the current substring is lexicographically smaller. So we'll come underneath this and we'll say if cur dot is empty, 2 vertical lines, open up the parentheses, cur length is less than cur dot count. Come outside of that, 2 more vertical lines, or cur length equals cur dot count, and 2 and signs, current is less than cur. Then we're going to open up the brackets and we're going to say cur equals current, just like that. Now, if the character leaving the window is 1, we're going to decrease the count. So we'll come underneath this and we'll say if R square bracket left, come outside of that, equals quotation marks 1, we'll open up the brackets and we'll say count minus equals 1. Boom. Then we're going to shrink the window from the left by coming underneath this and we're going to say left plus equals 1. Then we're going to expand the window by moving the right boundary by coming underneath this, and we're going to say right plus equals 1. And then we're going to return the shortest beautiful substring found. If none exists, the will be an empty string. So we'll come underneath this, and we're going to say return cur, y'all. Boom, let's give it a run. Oh, we got the wrong answer. So that means the math is not mathing somewhere. So let's see if we could find out where the math is not mathing. So let me check this real quick. Let me see. That should be good. Let's see. Because somewhere the math got messed up. So the question is where? One moment, y'all. Oh no, y'all. Let me see. Huh. Oh, right here, y'all. This should be while right is less than length, not left. So let's see if that fixed it. Hopefully it did. It should have. And it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 6 milliseconds beats 26.67% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, make sure you get one more look at the code. That's the top part. This is the bottom part, y'all. So yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.